Find the value of dy dx at the point 2, 4. And we could add to the directions by implicit differentiation. This is an implicit differentiation problem. Okay, so I'm going to take the derivative of both sides. The derivative of both sides with respect to x, treating y as a function of x. Okay, so that is the derivative of x with respect to x. That's an easy one. Plus the derivative of this term with respect to x. I'll go ahead and use my constant multiple rule and move the 2 out, minus the derivative of y squared with respect to x is equal to the derivative of 2 with respect to x. Okay, this is a step you might not need to do, but I'm just trying to stay organized here. Derivative of x is 1 plus 2. Now be careful, this one needs the chain rule. Right? It's the product rule. I have the product of two functions of x, so I got to use the product rule here, which means I'm going to leave x alone, take the derivative of y, plus, from the product rule, take the derivative of x, and then leave y alone. Y squared requires the chain rule, 2y dy dx, and that's equal to 0. Okay, so I can go ahead and run the 2 back through now. I got 1 plus 2x dy dx plus 2y minus 2y dy dx equals 0. Okay, so we're asked to find the value of dy dx at 2, 4. So it means I can plug in my 2 here and my 4 here and here, and then solve for dy dx. Or a lot of times we like to solve these for the derivative first, which is good practice. The algebra is good practice because a lot of times these questions ask for dy dx. So in other words, I want to isolate dy dx. Okay, so that means if I want this guy on its own, how do I do that? Well, typically we take the entire term that involves our derivative term and we get it on one side of the equation by itself and then factor it out. Okay, so that's the algebra we're going to employ here. So let's see what that looks like. That means I got to move this over and I got to move this over, minus 1 minus 2y. So I have first 2x dy dx minus 2y dy dx, my two derivative terms, equals negative 1 minus 2y. Now I can factor out the dy dx. That leaves me with 2x minus 2y equal to negative 1 minus 2y. And then I'll divide. And I've solved for dy dx is equal to this. Okay, now at the point 2, 4, I have negative 1 minus 2 times 4 over 2 times 2 minus 2 times 4. And that's equal to negative 1 minus 8 is negative 9. 4 minus 8 is negative 4 with a solution of 9 over 4.